Good morning, Morgan, and good morning to any of Morgan's friends that have joined us for this video. And today we're just going to do a little few odds and ends. We're going to read the manual, but the manual, man, it's freaking confusing. We're just going to look at the examples, and then we're going to run the examples, and we're going to talk about some more. But let's get this reading out of the way.
If the same attribute name occurs in both an instance and in a class, then attribute lookup prioritizes the instance.
Okay, well, what are they talking about? Okay, really simple. Remember to the other videos, okay, when you have a variable inside that's defined inside the class that isn't in a function method, it's going to be the same every time you create an instance of the class. And we do that twice. We create an instant here and an instant here. So at this point, there's two warehouses, okay? And inside the first warehouse and inside the second warehouse is always the same, storage west, okay? Unless they do something, all right? So here, they create the instance, and then they go to print the instance. And because you haven't done anything with what's in the warehouse, it defaults to the original values, okay? And it goes, oh, storage west. And then when it comes, creates this second instant of warehouse, okay? When it's created, it also has those variables, unless you come in here and you override it, okay? And then you go to print it, it comes out storage use. And that's what they were trying to tell us there. All right. Now let's continue and get ready for a lot of gobbledygook. I went ahead and created added some definitions in here so you can try and understand what they're talking about. You might have to replay this a couple times.
Data attributes may be referenced by methods as well as by ordinary users, clients, of an object. In other words, classes are not usable to implement pure abstract data types. In fact, nothing in Python makes it possible to enforce data hiding. It is all based upon convention. On the other hand, the Python implementation, written in C, can completely hide implementation details and control access to an object if necessary. This can be used by extensions to Python written in C. An abstract data type is a purely mathematical type, defined independently of its concrete realization as code. Data hiding is also known as data encapsulation, and it is the process of hiding the implementation of specific parts of the application from the user. An implementation of Python should be taken to mean a program or environment which provides support for the execution of programs written in the Python language. Clients should use data attributes with care. Clients may mess up invariants maintained by the methods by stamping on their data attributes. Note that clients may add data attributes of their own to an instance object without affecting the validity of the methods, as long as name conflicts are avoided. Again, a naming convention can save a lot of headaches here. There is no shorthand for referencing data attributes or other methods from within methods. I find that this actually increases the readability of methods. There is no chance of confusing local variables and instance variables when glancing through a method. Often, the first argument of a method is called self. This is nothing more than a convention. The name self has absolutely no special meaning to Python. Note, however, that by not following the convention your code may be less readable to other Python programmers, and it is also conceivable that a class browser program might be written that relies upon such a convention. Any function object that is a class attribute defines a method for instances of that class. It is not necessary that the function definition is textually enclosed in the class definition. Assigning a function object to a local variable in the class is also okay. For example.
All right, I hope that all made sense to you. All right, let's talk about this. All right, and they keep talking about scope. Did they talk about scope, or is that the next paragraph? Okay, well, we're going to talk about some scope here just to get you ready for what's coming next. Okay, so what do we have here, really? Okay, we define a definition or a function method, if you want to call it, called F1. We use the little self thing so everybody keeps track so nobody gets confused, right? but this is outside the class definition. So it's in the global scope. Okay, global scope. Then everything that's inside the class statement is the non-local scope. And anything inside a definition inside the class is local scope. Okay, so what do they do here? All right, so this is a global scope. Now you create the class, and inside your non-local scope, what do? You grab and create an instance of the F1 function inside the C, class C. Then you define another function called G, and then you create an instance of G called H. So you actually have 3 functions inside this class statement. This one, global. Okay? This one was created non-local because it's inside the class. Then we create G, right? So everything inside G is local. Then we come out and we create H in the non-local scope, but it's accessing something in the local scope. So they've got every different way of screwing with the scope possible here. Okay, let's keep reading.
Now F, G, and H are all attributes of class C that refer to function objects, and consequently they are all methods of instances of C, H being exactly equivalent to G. Note that this practice usually only serves to confuse the reader of a program.
No shit.
Methods may call other methods by using method attributes of the self-argument. Class bag.
Okay, so what's this? All this means is that you can okay, here we've got our class, and we've got our 3 rooms in the class. All right, in each room that's local scope, and then out here it's non-local scope, and outside of the class bag, it's global. So what they're doing here is they're actually accessing. Oh, they do it here too. Okay, so let's see. No. Okay, so they're accessing the data. They're creating a list. Okay, and then they go and they're screwing with the list. And then here, we've called this add. They're calling the add function to access the data that was created in this function, this list. And that's kind of confusion. I don't know why you do that, but there you go. All right, well, let's get this done and done with.
Methods may reference global names in the same way as ordinary functions. The global scope associated with a method is the module containing its definition. A class is never used as a global scope. While one rarely encounters a good reason for using global data in a method, there are many legitimate uses of the global scope. For one thing, functions and modules imported into the global scope can be used by methods, as well as functions and classes defined in it. Usually, the class containing the method is itself defined in this global scope, and in the next section we'll find some good reasons why a method would want to reference its own class. Each value is an object, and therefore has a...
Okay, all right. So I hope that you've had me explain it and you've had the machine explain it. I did create some sample code for this, but I really don't think we can really profit from spending any more time on this than we are right now. Anyway, so there you go. Hope that helped, and I'll see you in the next video.